Hello, welcome to Basic Aerodynamics. I am Senior Member Paula Kesler, Civil Air Patrol. There will be a post-talk quiz. Is this flight? 4 forces govern flight. These are drag, lift, weight, and thrust. Let's begin with drag. Drag, in total, is the force which opposes all motion through the atmosphere and is parallel to the direction of the relative wind. Drag consists of the sum of parasite and induced forces. Parasite drag is simply resistance to passage through the air. If we double the airspeed, the force of parasite drag is quadrupled. Think of a smooth versus rough surface providing less to more friction as airflow increases. Induced drag is the rearward acting force produced as a component of lift. The force of induced drag varies inversely with the square of the airspeed. Angle of attack is the angle of the wing airfoil as it encounters the relative wind. The higher the angle of attack, the higher the induced drag. Maintaining altitude in slow flight has greater induced drag than maintaining altitude in cruise configuration. Because it consists of 2 components, the total drag does not increase simply with an increase in speed. It decreases from minimum flight speed up to a certain speed and then begins to increase. The cause being that at low airspeed, the parasite drag is low, but the high angle of attack required to sustain lift results in high induced drag. However, there is very little induced drag at the low angles of attack associated with high airspeed, but the resulting parasite drag is high. The airspeed sweet spot, where total drag is the least, is the maximum lift-to-drag ratio, or LD max. At this speed, which varies with the weight of the airplane, the longest range in powered flight and the greatest power-off gliding distance can be achieved. A Cessna 210 best glide speed with propeller windmilling flaps in Europe varies from 75 knots indicated airspeed for 3,000 pounds to 85 knots indicated airspeed at 3,800 pounds. There is no lift without drag, and that brings us to the subject of lift. Lift is the force produced by a wing. Lift is developed as a result of motion between the wing and the air. Lift is influenced by several factors: the angle of attack, the shape and size of the wing, density of the air, and true airspeed. As you can see, an increase in wing surface area produces a direct increase in lift. The Cessna Model 210L power-off stall speed is 65 knots, but a change in the shape and size of the wing, flaps down, lowers the stall speed to 56 knots. Of course, there is an accompanying increase in drag, but flaps down flight is normally used in landing configuration where the point is to slow for landing. While on the subject of airfoil configuration, a contaminated wing surface raises the stall speed. There have been cases where frost on the wings has even prevented takeoff. If the wing area and air density are held constant, the coefficient of lift varies inversely with the true airspeed squared. That is, when the airspeed is reduced by half, the coefficient of lift must be increased by 4 times in order to maintain the same amount of lift. Just increase the angle of attack to increase the coefficient of lift. But wait, there are more factors at work here. Parasite drag shapes relative wind to the airfoil. Their flow is laminar, smooth, until true airspeed or angle of attack overcome friction holding flowing air to the wing. There is a point in this relationship of airfoil to angle of attack where the lift is destroyed and the force of gravity, weight, takes over. The air no longer has laminar flow over the wing's upper surface. Raise the angle of attack too high in an effort to maintain flight, and the smooth flow separates from, burbles over the wing, and lift is lost. This is called stall. You might wonder why the force of power from the engine can't take the place of loss of lift from the airfoil. Very simply, there just isn't enough of this force available from a conventional aircraft's engine. Some of the more powerful jet fighter types and aerobatic sport airplanes can, for a short distance and time, climb straight up without any significant help from the airfoils. But these airplanes will eventually stall and start to fall toward Earth. How are wings like mountains? They both produce downdrafts downwind. Air behaves the same whether the object it flows around is stationary, mountain, or moving, wing. Air around the wing develops a downward force equal to the weight of the aircraft in level flight. This is critical for aircraft following a large airplane, jetliner, on takeoff or landing. Air spilling over wingtips rotates. Generally, trailing wingtip vortices have dimensions corresponding to 2 wingspans in width and 1 wingspan in depth. These horizontal tornadoes, tests have shown they can reach velocities of 133 knots, are present most strongly at the points where a heavy, slow-moving transports rotate for takeoff or touchdown on landing. Wake turbulence avoidance tip. Take off at the point on the runway before the point where the heavy rotates and land after the point where the heavy lands. And now for a heavy subject, weight. What is weight? Weight is a force caused by the action of gravity on mass. The property of mass is the manifestation of potential energy transferred to fundamental particles when they couple with the Higgs field, which had contained that mass in the form of energy. For our purposes here, mass in a gravitational field, weight, is the force which must be countered by lift in order to fly. But wait, there's more. For the low cost of a properly executed turn, a bonus force. Turns generate centrifugal force, causing an apparent increase in weight. In addition, as the bank is steepened, the total lift must be increased by increasing the angle of attack to maintain flight. Caution, stall ahead. A bank angle of 60 degrees will produce a force of 2 times that of gravity. Abrupt changes in direction due to rough air also cause an apparent change in weight. How does the Cessna 210L with a wing load of 21.7 pounds per square foot keep from breaking its wing in rough air? The answer? Deliberately stall the wing prior to reaching airframe collapse. This upper speed limit, maneuvering speed, is weight dependent. For example, loaded to a total weight of 3,800 pounds, the maneuvering speed is 119 knots calibrated airspeed. But lighten the load to a total weight of 2,500 pounds, and this lowers the maneuvering speed to 96 knots calibrated airspeed. An interesting note, centrifugal force, in opposition to force, will decrease the stall speed of a wing. You can fly an airplane at 20 knots that would stall its wing at 75 knots under those conditions. Wow! Now for the final thrust to our conclusion. Thrust produces motion for flight. This motion overcomes drag and causes lift. Aircraft engines power thrust, but an airplane does not fall from the sky when the engine quits. There is energy stored in airspeed and altitude. And now to our post-talk quiz. Is this flight? Aerospace, the challenge, second edition reads, aerobatics flying requires an aircraft which can withstand tremendous forces and that aircraft can fly upside down, right side up, and everything in between. It also requires a particularly skillful pilot. The pilot must have very good vision, distance judgment, and be able to think and react calmly while under a great deal of pressure. Many of the best aerobatic pilots are women. Is this flight? Yes. In conclusion, I thank you for your kind attention. Good day.
An understanding of basic aerodynamics is key to any aviation career. If you have any questions, feel free to post them in the chat and we'll make sure they get answered. But it's very dangerous to try to fly a plane without knowing what makes the plane fly. So if you have a question, just please post it. Okay, I see we have a question on indicated airspeed versus calibrated airspeed. Well, the indicated airspeed is the airspeed that you see on the airspeed indicator. Calibrated airspeed is that indicated airspeed, but with a correction for position installation error. Equivalent airspeed is calibrated airspeed corrected for compressibility or altitude pressure. True airspeed is the equivalent airspeed corrected for temperature and pressure altitude. So there's airspeed, much like when you're plotting your course, a number of factors go into what the actual airspeed is. And it can have an effect on your calculation of said flight path.
And to refine a little bit, the position error as under the indicated airspeed is directly related to where the static tube is. It's when it picks up the inside pressure of the aircraft, so it actually sets off the airspeed a little bit based on pressure and location of where that instrument on the outside of the aircraft is mounted.
I hope we've answered your questions. Now, anything that that came up during basic aerodynamics is an important factor in learning to fly. But what makes the airplane stay in the air? Bernoulli's principle. As the wing cuts through the air, air goes below it and air goes above it. And when the pressure below the wing becomes higher than the pressure above the wing goes, you get lift and the wing goes up. But you have to be careful of getting into what's called a stall position, where you get burbling on the top of the air, where the air is just sort of milling about and it's not flowing across the wing properly. So burbling can put you into a stall. Wings are designed so that they have good flow over the wing. And one of the basic principles is, are you designing a wing for lift? Are you designing a wing for speed? So if you look at various types of aircraft, you'll see swept wings, delta wings, and you'll see your traditional wing that you see on a Cessna 172. And each type of wing has a specific purpose of gaining altitude really fast, gaining speed really fast, or maintaining speed. The amount of thrust and therefore lift that you get from a jet engine is different from that which you get on a traditional piston engine in your Cessna. So when you have the Cessna engine paired with the wing, you want to make sure that wing gets lift fast and keeps lift. Whereas when you've got a jet engine and a delta wing, the delta wing is designed to take advantage of the force from the jet engine. If there's additional questions, please feel free to reach out to Senior Member Kesler at pkesler@ilwg.org. www.cap.gov.